You know, we like to think we have a pretty good grasp on how big the universe is. But what if I told you that everything we've ever seen, every single star and galaxy, is just a microscopic speck? A tiny bit of dust in a reality so ridiculously vast, it's almost impossible to comprehend. Today, we're going to try and wrap our heads around the true scale of the cosmos.
Okay, but before we dive into the absolutely mind-bending numbers, let's just start with a simple question. Seriously, take a second. What is the biggest thing you can possibly imagine? Is it a mountain? Maybe a planet like Jupiter? Or our entire solar system? Whatever it is, get that picture clear in your mind and just hang on to it.
All right, you got that image? Good. Before we completely shatter that picture, let's set the stage. We'll start with what we think we know, the established facts about the size of our universe. The key phrase you always hear is the observable universe. Now, it's really important to get this. That's not the entire universe. Think of it more like our own personal cosmic bubble. It's everything whose light has had enough time, about 13.8 billion years, to travel all the way across space and finally hit our telescopes. Anything outside that bubble? Well, for now, it's completely invisible to us. And let's be clear, this bubble we can see is already gigantic. I mean, we've actually measured it. It's about 93 billion light years across, and we estimate there is something like 2 trillion galaxies packed inside. So for all practical purposes, it feels absolutely immense. This is what most of us are picturing when we say the universe. But what if that feeling of immense is just the tip of the iceberg, a really, really tiny tip? That brings us to our next part. We need a new cosmic yardstick. Because it turns out our baseline understanding, it's radically incomplete.
And here's the question that changes everything. What if our entire known universe, every star, every nebula, every single galaxy we have ever seen or photographed, is just a vanishingly small fraction of the total picture?
Now, this isn't just some wild guess or a cool sci-fi idea. It's actually based on some pretty solid models of what happened in the universe's very first moments, right after the Big Bang. This idea is explored in research about the infinite scale of the unseen universe, and it helps calculate the true scope of the reality that lies forever beyond our view. So this leads us to the ultimate question, right? If our observable bubble is just one tiny piece of the puzzle, how much bigger is the total universe? Are we talking, what, twice as big? 1,000 times bigger? Maybe 1,000,000?
Okay, get ready for this. According to the models, the total universe is at least 150 sextillion times larger than everything we can see. Let me just say that again so it sinks in. 150 sextillion. That's a 150 followed by 21 zeros. It's a number so vast our brains can't really even process what it means.
So, what on earth does a number like that even mean? How is that even possible? Well, that takes us to our next section, as we try to explore this unseen universe, the vast part of reality that lies forever beyond our horizon.
This really gets to the heart of it. See, in the very first fraction of a second after the Big Bang, the universe went through this insane growth spurt called inflation. It expanded way, way faster than the speed of light. Our observable universe is just the little patch whose light has had time to catch up to us since then. But the total universe? That includes all that other space, regions that expanded away from us so fast that their light will never, ever be able to cross the distance to reach us. Ever. To try and put this into perspective, think about this analogy. If the total universe were all the beaches on planet Earth, every grain of sand on every continent, then our entire observable universe, with its 2 trillion galaxies, would be smaller than a single grain of sand.
Once you start to grasp that, you realize this doesn't just change a number. It completely reframes our reality. It opens up, well, a universe of possibilities.
So what does this all mean for us, really? Well, first, it confirms that our world isn't just small, it's a fraction of what amounts to a cosmic rounding error. But, more importantly, it means the boundary of our knowledge is not the boundary of reality. Just because we can't see it doesn't mean it isn't there. And that's the most exciting part. The potential for the unknown, for different laws of physics, different kinds of matter, things we can't even begin to imagine, is pretty much infinite. So in the end, that number, 150 sextillion, it's not just a cool piece of trivia, it's a profound redefinition of our place in the cosmos. It's a shift from feeling small in a big universe to realizing we are a microscopic part of something that is fundamentally, beautifully, and maybe even terrifyingly beyond our comprehension.
And that really leaves us with one final awe-inspiring thought to chew on.
If reality is 150 sextillion times larger than what our greatest instruments will ever be able to show us, what does that imply about the scale of our own potential for discovery, right here, in the one tiny corner we can actually explore?